The topic for Lesson 4.1 is classifying triangles, and the two ways we classify triangles are by their angles and by their sides. Why are triangles important in construction? Many structures use triangular shapes as braces for construction. The roof sections of houses are made of triangular trusses that support the roof and the house. There are three ways to classify triangles by angles. In an acute triangle, all the angles are acute. In an obtuse triangle, one angle is obtuse, and in a right triangle, one angle is right. An acute triangle with all angles congruent is an equiangular triangle. For example 1, the triangular truss below is modeled for steel construction. Classify triangle JMN, triangle JKO, and triangle OLN as acute, equiangular, obtuse, or right. Okay, let's find triangle JMN. Okay, that's our big one. It looks like angle N is bigger than 90, so that one will be obtuse. Triangle JKO, that sure looks like it's a right angle, so that is right. And triangle OLN, it sure looks like the angles are all the same. I wish they'd actually said that, but we're going to make believe that they are, and so that one will be equiangular. The other way we can classify triangles is by their sides. To indicate the sides of a triangle are congruent, an equal number of hash marks, or I call them tick marks sometimes, are drawn on the corresponding sides. If we have no two sides congruent, it's a scalene triangle. In an isosceles triangle, at least two are congruent. And in an equilateral triangle, they are all congruent. So that would mean that an equilateral triangle is a special kind of isosceles triangle. Example 2a, they ask us to identify the isosceles triangles in the figure if UV, okay, they didn't mark that, UV is congruent to VX is congruent to UX. Huh, interesting. Okay, so the isosceles triangles are going to be, they already had marked the UT and the TX, so we could have triangle UTX, and then we just marked the other one, so triangle UVX. For example 2b, they're starting with the same diagram, but they want us to identify the scalene triangles. Well, I see one here, and it overlaps here. Okay, we can't use that guy's isosceles, he's isosceles. That looks scalene. Okay, I just erased my writing because it was kind of looking messy, but here we go. Let's see if we can just follow the letters. We've got V, Y, X, okay, we had that one, and Z, T, X, we had that one, and then V, Z, U, and Y, T, U, we had those, and V, W, X, we had that one, and Z, U, X, oh, I missed that one, and Y, X, U. All scalene because their sides are all different lengths. For example 3, they ask us to find D and the measure of each side of equilateral triangle KLM if KL equals D plus 2, LM equals 12 minus D, and KM equals 4D minus 13. Okay, the first thing we need to do is find D. I'm going to pick the two easiest expressions since they're all equal to each other, since the sides are all congruent. So we have D plus 2 equals 12 minus D. Add D to both sides. So 2D plus 2 equals 12. Subtract 2 from each side. So 2D equals 10 and divide by 2. So I get D equals 5. Great. Now they ask me to also find the length of each side. Okay, so the first one was KL is D plus 2. So if D is 5, 5 plus 2 is 7. And then LM is 12 minus D. So 12 minus 5, 5, getting ahead of myself, is also 7. Wow, I said LM and I wrote LL. That's great. And then our third side was KM is 4D minus 13. So 4 times 5 minus 13. 20 minus 13 is also 7, which is what we wanted. So that was kind of a little check step of sorts. Never hurts. Once you did one, you should have had them all, but it's good to check. Okay, for our last example, they asked us to find the measures of the sides of triangle RST, then classify the triangle by its sides. Again, we get to practice the distance formula. Now, on example 4, since they graphed it for us, I am going to use the graph that they gave us to count the sides for our right triangles. So for side RS, it's going to be the square root of, okay, from -3 to 4 should be 7. And from -1 to 4 should be 5. So I get the square root of 49 plus 25, which is lovely. We're just going to leave it the square root of 74. Okay, for ST, from 4 to 8 should be 4. And from 4 to -1 is 5. So a squared plus b squared still equals c squared. Lovely. I know this is definitely not equilateral. Let's do RT. So from -1 to 8 is 9. And from -3 to -1 is 2. So 81 plus 4 is 85. I already knew from the first two that it was not going to be equilateral, and they're all different. So we know that triangle RST must be scalene. They are all different. Okay, so yes, a triangle is a three-sided polygon. Triangle ABC is written triangle ABC and has parts that are named using letters A, B, and C, capital letters. The sides of triangle ABC are segment AB, segment BC, and segment CA. The vertices are A, B, and C, and the angles can either be named using 3 letters with the vertex in the middle or just 1. And summing up our ways of classifying triangles can either be classified by their angles as acute, obtuse, or right, or classified by their sides as scalene, isosceles, or equilateral.